So for the first one, what did you guys try to let u equal? Yeah, the exponent, like the inside stuff, or the thing with the highest power. And then, so your derivative is 2x plus 6 dx. Now you want to look at what you have in the problem. If I multiply that by 4, I'm going to get this. So I'm going to do 4 du equals 8x plus 24 dx. And so then if you want to highlight, circle, underline, whatever you want to do, we're going to replace the 8x plus 24 and the dx with 4 du. So we're going to remove that stuff. It's used substitution. You're substituting. So we're going to remove that stuff, replace it with 4 du. What is still there? E to the u. Now you're going to do an antiderivative, but what is the antiderivative of e to the u? Yeah, e to the u. So it looks like you didn't do anything, but the way you can tell you did an antiderivative is you no longer have your integral symbol in your du. Instead, you have plus e. So that's how you can tell that that step actually happened. And then your last step is to plug this stuff back in. So for this one, you would let u equal the stuff that's in the parentheses, so like the guts of it. That derivative would just be what? Yeah, like literally just 4 dx. And so we're going to adjust with a 1/4. And so the only thing that you get to substitute in this case is the dx. Sometimes that's the only thing you get to substitute. We're going to put 1/4 out front, du at the end. What's still there? Yeah, u to the 7th. And then we're going to adjust the boundaries. It's really easy to do. You just have to remember, you're going to plug them in right here. So if you plug in 1 for x, 5, good. And if you plug in 5 for x, 21. Don't forget to actually do an antiderivative. That's the most common mistake with these. And I totally get why it happens. You feel like you already did the problem, right? Like you already did a lot of work. Don't forget to do that step. What's your antiderivative of u to the 7th? 1/8 u to the 8th. Now, there's also a 1/4 there, so I'll write it, but I'm going to erase this in a second. If you multiply those together, you would get 1 over what? 32. Good. Such that 5 to 21. Now, you don't have to substitute the 4x plus 1 back in because we took care of that with the boundaries. So you get to skip that step. You're going to do fundamental theorem of calculus, which is upper minus lower. So it's going to be 1 over 32, 21 to the 8th, whatever that is, a very large number, minus 1 over 32, 5 to the 8th. And it is not multiple choice on your quiz, so you can simply leave it alone. Okay, that sounded like that went okay. All right, so for this one, you're going to let u equal the 5x, the stuff inside. The derivative is just 5. You adjust it with a 1/5. So again, for this one, the only thing you get to substitute out is the dx. Sometimes that's kind of just the way it is. What's still there is negative cosine u. So you need to come up with a function that if you did the derivative, you would get negative cosine, which would be what? Yeah, negative sine. I'm going to leave that 1/5 out front. So negative sine u plus c. And if you multiply a negative, or you think of it like a -1 times 1/5, I'm just going to put the negative out front. So it's negative 1/5 sine of 5x plus c. Yeah. So for this one, we're going to let u equal, again, the inside part. Derivative is just 3, and we're going to adjust with a 1/3. That part is just, are you guys like kind of just churning that out at this point? That's a process. You just go through that. So in place of dx, you're going to put 1/3 du. What's still there? Now it's square root of u, but you would want to write that as what? Yeah, u to the 1/2. Good job. Now we're going to adjust the boundaries. If you plug in 0 to this, you get -2. If you plug in 4 to this, what is that, 10? Don't forget to do the antiderivative. That's why writing the integral is really important. So I do need to see that. So you're going to add 1 to the power. We don't write 1½ so it would just be 3/2. That means in front of that is a 2/3 and that 1/3 that we had that was outside. I'm not going to put plus C. I'm going to put such that -2 to 10. Yes. When you're doing a derivative of square root, that's 1/2 square root. We are doing antiderivatives. But again, and I was saying that over here too, that happens once we switch to antiderivatives, this happens a lot because you have derivatives and you have antiderivatives. And I know you're not going to like this answer, but it's just going to come from practice and just being really, really vigilant and careful. All right, so we're going to do upper minus lower. And I am going to need to go back and fix that because I never noticed this, but you are correct. When you plug in 10, oh, and what would this be out front? That would be 2/9. And then you would have 10 to the power 3/2. Now I'm going to let you just leave this -2 to the 3/2. But because it's halves, that means square root. You would end up square rooting a negative number, which is imaginary. And we don't do imaginary numbers in calculus, but I'm going to leave this because that's what it came out to. Just leave it alone. We'll pretend that didn't happen, okay? All right, and then last one. What do you want to let u equal for this one? Yeah, the 4x cubed minus 8x. The thing with the highest power, or what did I say to choose? The denominator. If you aren't sure, pick the denominator. So then that derivative is 12x squared minus 8 dx. And now I need to make it match what's in there. It's going to work. I can't give you an undoable problem. What would you do to adjust this? Yeah, we're going to divide by 4. So 1/4 of this is 3x squared minus 2, which now it matches what's in the problem. So, and yes, you are correct, but you're ahead of me. Just give me a second. So this is, no, you're good. I'm happy that you're rolling through it. So in place of those two things, we're going to put 1/4 du. What is still there? 1/u. Yeah, the denominator part. And then your antiderivative of 1/u is ln. And your last step is to put the 4x cubed minus 8x back in there. You do need the absolute value. When did I say you're allowed to drop it and you don't have to write the absolute value anymore? Once you plug a number in, because if you do the absolute value of 7, it's just 7. You don't need to write the absolute value anymore. But if it's still variables, you do have to have it.